What's up, everybody? Welcome back to Built for Life. My name's Joel, and today we're taking a look at the Shapeoko 5 Pro 4x4. And we're going to try to answer a question that I had when I was buying this, and hopefully it helps you guys out, helps you visualize a little bit of it if you're thinking about buying a 4x4, and that is, will it actually cut 4 foot by 4 foot? Now, if you've watched the Carbide 3D or Carbide Create videos, then they're going to sit there and say, hey, you know, it cuts 4 foot by 4 foot, da 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 da. So we're going to fact check them, and see if it will actually cut 4 foot by 4 foot. Put a ruler to it, actually move the spindle, measure it, see what it'll do, and see if there's anything that prohibits you from cutting it. I have some ideas, but we're going to take a look at it together, and I'm going to show you what I've found. So the first measurement we're going to take a look at is between the rails. Will a 4 foot piece actually fit between the rails? The quick answer is yes, but how much will fit between the rails? That's the question. It's about 55 1/4. So any material that is 55 1/4 or smaller will actually fit on the machine and between the rails. Now, that's fine, but you got to be able to hold it down too. So now the next measurement we're going to look at is the T-track, or your hold down options. How wide is your hold down options? So outside measurement to outside measurement, so from outside of the T-track to outside of the T-track on this side, we are looking at approximately 51 1/4. So 51 1/4 inches from outside of the T-track to outside of this T-track. So the next measurement I'm going to look at and show you is the wood slats. So from outside of the wood slat to the outside of this wood slat, how much room do you actually have? Okay. So from outside of the wood to outside of the wood over here, see what we got. Not much of a lip to stick it on. So outside of the wood to outside of the wood, you're looking just a hair under 47.5 inches. 47.5 inches, that's not quite 4 foot. Let's take a look at some other measurements. So the next thing we're going to do is I have a V-bit in there right now, and I'm going to drop it down. I have a 48-inch ruler, and I'm actually going to drop the point of the bit down as far over this way as I can on the x-axis, and then down, and then I'm going to line this ruler up with that and see how far the actual travel of the spindle actually is, whether it's 48 inches or not. All right, so now that we've seen that the spindle will actually move beyond 48 inches and plenty of room to actually cut 48 inches, I'm going to show you a little something else that I'm not sure Carbide Create thought about when they were putting this together. So I'm going to take this ruler, and if you see right here, this is the, what do you call this thing? BitZero. This is the BitZero. It's a pretty large bracket. It is mounted to the outside rail of the T-track. It is mounted as far on the x-axis as it will go, and as far forward on the y-axis as it will go, and still hit the bit. I cannot get this BitZero any further that way on the x or any further this way on the y, and it still work properly. And if you'll notice here, this BitZero bracket comes right up to the edge of the board. So what I'm going to do is I'm going to take this 48-inch ruler, I'm going to butt it up against this BitZero, because that is your limiting factor as far as the size of the material that you can get on, as long as it's a full 48 by 48. And then I'm going to square it up, and we're going to run this spindle as far as it will go on the x-axis and see if you can still cut 48 inches. So now I've showed you the visual with the 48-inch ruler and where the problem lies with this BitZero. But now I'm going to actually put a 4 foot by 4 foot piece up there and show you, to give you a better visualization of what it looks like with a half sheet on there, and then what are some problems that I've encountered while trying to cut a full half sheet or 4 foot by 4 foot sheet. All right, so we got our board up here, and now what I want you to take a look at is this right here. So this 4x4 hits right into this BitZero. And now if we bring the spindle all the way down, and I'm not going to bring it all the way down wide, but I'm going to bring it so that you can see it. And then we're going to drop it down. So you can see with this BitZero on here, you're losing about 3/16 of an inch in your cut capacity. So if I were just cutting material on this, I'll be honest with you, I'd disable my BitZero and move it off the board. That way it opens up that 3/16. And then at that point, without the BitZero, you can actually cut 4 foot by 4 foot. So if you had something that was larger than 4 foot, you could actually cut a 48 by 48 on the, like if you do a line, you could do outside the line 48 by 48, with a 1/4 inch bit. You can actually go all the way up to a 3/16 of an inch bit and cut outside of the line on a 48 by 48 inch square. I hope that makes sense. All right, so we've got this piece of 3/4 inch birch that's been painted black on the top. You'll see why later. On here, and you'll notice, you may or may not notice one problem, and that problem is your hybrid table that is so well touted by Carbide 3D, which I love this hybrid table, don't get me wrong, but how do you hold it down? So the only thing that you have available to hold it down are these black T-tracks along either side at its outermost widths. So, which is fine. Your standard Carbide 3D clamps that come with the machine, or in the Clamp It kit, the Crush It kit, whatever they call it these days, will fit in there absolutely fine, and you can get it on the edge, and I'll show you how I use it. One issue with that again is your BitZero again. You have to load in the T-track nuts only from the back side of this side, because this is clogging up or holding up or whatever you want to call it. It's the outermost one, you can't get them in from the front because the T-track nuts that are holding the BitZero on are blocking it up. So you have to go from the outside, or you have to use there's one that's another T-track that's right next to it that's inside. You can use that one because you can slide it underneath and then put it in. And then all along this opposite side, you can use it. But one problem that I'll show you that I have with this, so here, if we take this hold down and we put the T-nut in the T-track and we slide it down to where you can see it, you can see that if I put this on here, it's going to be at a pretty sharp angle, and it's actually got more force pushing inward against it and kind of pinching the wood in than it does like hold down. So one thing that I do is I make these little, it's just a piece of plywood from some scrap. It fits inside of this area here so that it gives me something to prop up the back side of the clamp to create a better angle to put downward force on the material as opposed to pushing inward on the material. And I found that this holds really good along the edges. Now, if you have some laser straight and laser flat plywood, clamping it along these edges is totally fine, and you can clamp it and cut all day long. The problem is even the really expensive plywood, even this premium sheet of plywood that I've purchased, like a $80 sheet of plywood, 3/4 inch birch plywood, is not perfect. It's got some bow to it. So if you're just cutting out shapes in this plywood, probably be totally fine. You can zero off your bed and then cut your shapes totally fine. You may want to run your first cut pass a little bit shallower than the rest, just in case it is higher and it doesn't take a larger bite out of the material than you expect and possibly break a bit. But nevertheless, it will do it and it will work great. Now, if you're wanting to cut designs and pocket and have stuff look nice, or even do a nice VCarve in this plywood, then even a 1/16 of an inch in bow, when you're trying to VCarve a detailed design, is going to affect your cut It's going to make it not look right. If you're doing, let's say something like stars is pretty common. We're going to do some stars on this. If there is a 1/16 of an inch or more difference in the thickness or the elevation of this wood closer to my spindle, it is going to affect the detail of cut. So then, that being said, I want to be able to put some downward pressure in the center or along here. So how do you do that? Well, the best way to do it is screws. And if you're cutting a pattern that is, let's say, symmetrical or squares, the plan for this one is to cut a bunch of flags in this one. So if that's the case, I can just find the center and screw right down the middle and make my design not hit it. Putting something in the middle feels right. Everything's evenly spaced, feels good. The only problem with that is if you set this up on this 4x4 up, the middle of that, 48 inches, the middle is 24 inches. What's right at 24 inches? The middle T-track. Now you could use that to your advantage. If you wanted to drill a hole, slide a T-nut in there, and try to fish that in there. I don't think that's plausible, and I don't want to deal with that. So what I end up doing is, for this particular one, I come over 25 inches and to this piece of wood and put my screws in, and then I have to represent that on the design and the cut. And I'll tell you what, let's hop over to Vectric and I'll show you the design and I'll show you how I go about putting the screws into the design so I don't hit them.
All right, so this is the art that we're working with today. It is 8 flags on that 4 foot by 4 foot material, 6, one for each branch of the military, and then 2 fun ones. So this is the area where we're going to try to run our screws. And to make a zone, I'm going to use guidelines, and you can simply take your cursor over here to the ruler area, click, drag, and hold, click, hold, and drag, and then put it in the middle, and then you'll see that measurement that comes up beside it as you move along. Now that is measured from the datum. So as you move it along, it's telling you how many inches away you are from your datum or your zero or your home, whatever you want to call it. In this case, our datum is in this bottom lower right corner. So now we've got the center line. That's where we're going to put our screws. And I want to visualize a zone so I can make sure that my tool paths are not coming into contact with those screws. So what I'm going to do is I'm going to create a new parallel guideline. I'm going to do it relative to the guideline that I just drug to 25 inches. And the first one is going to be negative a quarter inch away from this guideline. So I can click create, and it just popped a new one right there. Now I can go in here and I can get rid of this negative, and I can go plus a quarter of an inch and create a new guide, and it pops one right there to the right. So now I've created a 1/2 inch zone in the middle of this board where I can put my screws, and as long as I don't run my tool paths into this 1/2 inch zone, then I should have no problem and with my bits coming into contact with screws. So if I measure from the edge of this flag over to the nearest guideline, I've got 0.3 inches, which is plenty of room to run a quarter of an inch bit along the outside of this line and not impact this zone. So once we get everything set up on the machine and start cutting, we should end up with something like this. So you can see why I painted it black. I paint it black, and then all the area that I remove is a lighter color, with that Baltic birch plywood being very light, and it usually comes out pretty good. Let's get back over to the table.
All right, I hope all that design work makes sense, but now we're going to talk just a little bit more about getting the material on the machine and getting it squared up. So we've got it on here, and the next thing to do when you put material on there is to get it squared up to machine. And usually, with a smaller piece of material, I would use a square and I would run it in my T-tracks, and I would, square it up, and everything would be fine. Unfortunately, with the 4 foot by 4 foot piece of material on there, it covers up all the T-tracks, so you don't really have anything to square off of. So the way I do it is pretty simple. If I'm running my BitZero, which I am on this design, because like you saw, we're doing some pocketing and some design, I will butt it up against my BitZero right here, because that's as far as I can go that way. And then I'm going to put my bit on the edge. So I've got it lined up with this edge, and then all I'm simply going to do is raise it up and run that y-axis all the way back, and then I'll lower it down again, because if it's pushed up against this side can't go any further this way. So now I'll just go all the way to the back, drop it down, and line that back edge up with the point of my V-bit, and it is squared up with the gantry, provided this side or this edge is straight. So if it's askew, then obviously your machine's going to be off, because what you're doing is squaring up this edge. So there's the back. And that's pretty much lined up. All right, so we've got this edge lined up. We've got this edge lined up. Everything's square with the machine. I'm going to put I have an edge bracket over there. I'm going to put a bracket on this edge, and then I'm going to show you how we find the screws in the middle. So I got a bracket holding each side down. The board's not going anywhere. I'm going to show you how we're going to find where the screws go in the center. So simply, easily, you can just use a tape measure, measure over to that 25-inch mark it, put a screw in there, right? Because in the design, you'll have a 1/4 inch on either side of that 25-inch mark, so a full 1/2 inch that is not going to be cut into. Then the problem comes the next screw. Am I going to lean all the way over here and do this all the way down? I don't need to. I have a measuring device. This machine has a measuring device. So what I'm going to do is, now that I know that the bit is on this edge, is on my X0, all I have to do is go to set 0 and 0 the X. I didn't 0 Y, I didn't 0 Z, all I did was 0 X. Now I'm going to come up so I don't hit anything. Now, I'm trying to see if I can get this glare off. Probably not. Okay, maybe not. Let's see. So on this edge here, in Carbide motion, is your position. Now we have X0'd here. That is a wasp. Dead wasp. Okay, so we've 0'd X. We know it was on the edge of the board. Now all we have to do is use this readout here to measure over 25 inches. And that'll tell us exactly in 25 where the screws need to be on that 25-inch mark. So I'm going to cruise this puppy over, and I'm watching here. It's going negative, negative, negative. All we got to do is cruise it over to -25 because I have mine set up in inches or freedom units. All right, -25 and 1/1000. That's good. That's fine. So now all I've got to do, drop my Z down so that I can see where it's at. And then run my Y down. And I can do this a couple different ways. I could actually just turn that on, lower it down enough to where it's barely touching, and actually just scribe a line and run screws in it all the way down. Or I could just move to a spot, get up there, run a screw in, move it, run a screw in, move it, run a screw in. It's fine. They both work well, and I found that this holds down, gives it a lot of vertical pressure flattens everything out, so that we can get a good design, so that we can get a good VCarve design out of it. So there you have it, 25 inches measured, and now I can just run it down and
put my screws in.
really now all I got to do I can even go so far as to make a little touch the wood. Come back up. And now I have marked my spot for my screw. Screws I'm using to hold this down are 1-inch coarse drywall screws. They just have a larger thread to grab that MDF a little bit better, and I just have had pretty good success with them. Now this is a perfect example of why, if you're gonna have a 4x4 table and you're gonna have it like up against the wall, whatever table or configuration you build, I recommend putting it on casters so that you can just roll it away from the wall and then access the back. Now, if you think this table is cool and you want to see where I got it, check out this video. and or maybe it's over here. I don't know. Maybe here. Maybe here. I don't know. Check out that video, and you'll see exactly how I made this giant table. And sorry about the music on the video. All right, guys, that's going to be the end of this video. We learned that with this Shapeoko 5 Pro 4x4, you can actually cut 4 foot by 4 foot, especially if you take this BitZero off. If you don't take this BitZero off, you've got to make sure that you're not going to hit it with your bit on this side, and then on this side, you're going to lose a little bit. If you're using a 1/4 inch bit, you're going to lose an 1/8 inch. If you're using an 1/8 inch bit, you're going to lose about a 1/16 of an inch. All in all, I don't think it's that big of a deal. I also showed you how I like to clamp a piece of material this big down to the machine using these spacers and in the software to protect your bit against hitting these screws. So I'm going to get to cutting this. If you want to see the final product of this, jump down in the description. I'm going to have a link to my Instagram page. I'm also going to have a link to our Facebook group. And eventually, when I get the time to finish these, I will post a picture of the final product of these. If you like what you saw and you learned something, consider hitting that thumbs up button. We appreciate it. Oh, and if you saw something in the video that you like and have a question about, drop a comment. I always get questions about this table. In the description, I'll leave a link to the video of me building this table. I also always get questions about this laptop mount on the table. I will leave a link in the description to that laptop mount. If you want to see more content like this, consider hitting that subscribe button, ring that notification bell. YouTube will let you know when I drop a new video. And then speaking of other videos, if you want to see how you can make some other interesting stuff, maybe something out of metal with your CNC, consider checking out these videos that I'm posting here. And we'll catch you on the next one.